Warm welcome to another session of fluid power. So today we are going to discuss about hydraulic circuit elements. So in a hydraulic circuit, you know that there will be a prime mover, then pump, different types of valves and connecting systems and the control elements. So all these things could be represented with simple line diagrams which will represent each of the components. These are very simple, but in an elaborative way, one by one, we will discuss in this session. Okay, so let us proceed without any further delay. So hydraulic system components, the symbols of these components. So if these are hydraulic circuit symbols or hydraulic component symbols, are a family of symbols which has been developed universally. So it is universally adopted. Similar to what we say, engineering drawing is the language of engineers. Similar to that, these symbols are universally accepted. So to overcome the barrier of language, anybody from any part of the world can read the meaning through these symbols. So International Standard Organization ISO has the control over the symbols used internationally. So similar to that, similar to ASME standard in America, there is one standard. In UK, there is another standard. But still, universally, internationally, ISO is the controller over this, or the use of and adaptation of these symbols. Standard symbols allow persons to read hydraulic power system drawings irrespective of the country which they are from. So that is the advantage. So if you read the hydraulic system, hydraulic power drawing, which has come from America, for example, you can simply read that without any write-up to support that. So that is the advantage. Or if you draw a circuit diagram and if you send to NASA, they can read that. If you draw it to as per the standard ISO. So basically, these shapes are added or subtracted from the drawings in order to get the different symbols. Circle, semicircle are used, for example, for rotary devices. So from the shape itself, we can see it is a rotary device. So pump, compressor, motor, all these things could be represented using a circle. Then valves are usually represented by square or rectangle. Similarly, the cylinders. Cylinders also, in almost all the diagrams, we represent cylinder using a open rectangle with a piston. Then conditioning devices like filter or cooler represented by a diamond shaped square, rotated 45 degree. Flow control elements are represented by two arcs like this, placed like this. Then a spring, usually used in valve spring control, is represented by zigzag lines. Okay, so these are the basic symbol shapes. Using this, the combination of this will give you many different parts or components of the hydraulic system. It will give you the meaningful diagram. The first category of hydraulic elements are energy conversion elements. Energy conversion elements. Pumps, motors, compressors, and drives. So these are the different energy conversion elements in which mechanical to hydraulic, hydraulic to mechanical, or electric to mechanical, all these energy conversions are taken. So coming to the hydraulic pumps, you can have the energy converted from mechanical energy to hydraulic energy, right? So the arrows used in hydraulic elements will be of closely filled triangles. This means use liquid. In pneumatic system, it will be openly filled. I mean, there will not be any filling inside. There is no solid. It will be open arrows. So closed arrows, but there won't be any black color lights. So a solid filled triangle makes this a hydraulic pump. So there is no other options for this particular pump symbol, which can be accurately described as a fixed displacement unidirectional hydraulic pump. So this is a unidirectional, a single arrow. If you have seen these double arrows on either sides, which means the pump will deliver in the both the directions. This is a birotational pump, or can deliver fluid in both the directions. Now coming to the hydraulic motor, so this is the input, and the motor, what will it do? It will convert hydraulic energy to mechanical energy. Okay, similar to the turbine. So there also we can have a unidirectional or bidirectional. So the hydraulic energy will be converted to some mechanical rotation at the center shaft. So that's why the arrow is pointing towards the center. So what will be coming, and it will be rotating the elements, and it will cause the shaft to rotate. Right? So that is the hydraulic motor symbol, unidirectional and bidirectional. Now there may be devices which can work as a pump or motor, which is usually represented by the arrows like this, both arrows, inward directional and upward directional arrows. So this is for a bidirectional pump / motor system, which can operate both as pump and motor. Now coming to the compressor, you can see the difference here. The arrow is not solid filled. It is not at all filled. Okay. So compressor converts the mechanical energy to pressure energy. So which uses air as the working fluid, compressible fluid. And coming to the air motor, the direction of arrow is towards the center, and the pressure energy is converted to mechanical energy. Now coming to the drives, which provide mechanical energy to the system. So this is your electric motor, and you can have this pump. So motor is usually represented by a circle with M written inside, and IC engines are usually represented by two rectangles, the smaller one inside the bigger one, like this. A small offset is given to the larger triangle, so it will become a IC engine. So this is a drive system. So electric motor or internal combustion engine can give power to the pump, or again different types of pumps or compressors. So these are all the first energy conversion elements in a hydraulic system. So we will stop here. We will continue in the next class with the second category of devices.